So by the extreme value theorem, we needed to test value of that original function at the endpoints and at the critical value that is strictly in between. And it's not so difficult to see what we would have from the endpoints. It's going to take a fair amount of work, though, plugging this in. Putting in 0 for x, 0 squared is 0. A squared plus 0 would be a. Square root of a squared, since a is strictly positive, is a. Putting in 0 for x over here, c minus 0 is c. So we'd have the square root of b squared plus c squared. It's going to be very similar when we put c in at the other endpoints. First square root would give us a squared plus c squared. Adding to that what we get from the other square roots. Well, c minus c is 0. 0 squared is 0. B squared plus 0 is b squared. Since b is strictly positive, the square root of b squared would be b. Let's use some space down here to plug in the value of x that we found for the critical point. This is finding out value of t at that point. Whereas this was t of 0, and this was t of c. All right. So first of all, I'm going to get a common denominator here. A plus b, multiplier to top and bottom. Distribute the c to the a plus b. And when we put together these two fractions with the same denominator, then subtracting those numerators, we're going to get the ACs to cancel. So that under that second square root, after the b squared, all that's left of the second term being squared there under the second square root is bc over a plus b. In each case, on that second term, under each square root, I'm going to split up the squaring across the quotient and across the product in the numerator, taking two steps in at the same time. And seeing that, within the first square root, I'm going to factor the a squared out of both of those terms. And on the second, similarly, b squared. That's starting to look a bit nicer. Let's get a common denominator again. And then add. Same for both of these square roots. That's all right. Now that may not look as nice as it did a moment ago because I've got the common denominator. However, things are really going to shake out pretty quickly here. Split up the square root across the quotient and then across the product that's in the numerator, taking those two steps at the same time. The same for the second square roots. Because A and B are strictly positive, A plus B will also be strictly positive. So taking the square root here, here, and in the denominator, here's what we see. There's from the first square root. There's from the second one. And I'm going to factor out the square root in the numerator here and here are the same, and we've got the same denominator. I'm going to factor out those, and we'd be left with a plus b from here times this. Remember, we'd already mentioned that a plus b could not equal 0. These are going to cancel out. And we are just left with the value of the original function t at the critical value of x is this.